Hey, everybody. So, we're going to be continuing our chapter on triangle proofs today. We're looking at 6.3. Um, in 6.2, if you remember, we were focusing on the reasons for our triangle proofs. Today, you'll see we're going to be focusing on the statement parts. Okay, but I'm still starting with this slide here because knowing the reasons and kind of how they flow with one another is still a really important thing. So, in your notes, have this next to you. It'll still help you out as you go through, your this lesson today. All right, and then as always, the very last reason on all of these is going to end with one of these triangle congruence theorems. All right, but yeah, if you take a look at today the worksheet, like I said, all of the statements are blank today. All of the reasons are given. All right. So in some ways, this is kind of easier than our last lesson because I think wrapping your brain around the reasons part is a little tricky. But yeah, let's just see how it works with the statements here. So start at number one here. Just like before, if you guys remember, where we always start is with this first piece of given information. Okay. And that first piece of given information is always going to be your very first statement. All right. So, let's just go ahead and get it down. So segment AB is congruent to segment AD. Why do we know that? It's given. And, as you go through this, double check that the reason that follows, is what you're expecting, because you can find some mistakes that way. All right. As always, we want to show this information on our triangles. So segment AB is congruent to segment AD. Okay, that's all we can get from that statement. So moving on to our next one, we have another given statement. So there's going to be our next thing. BC is congruent to DC. All right, why do we know that? Again, that's given to us. Let's show it on our triangles. Here's BC, here's DC. Okay, so, we have two pieces of information. We now need to find this third thing on our own. Hopefully, we're all getting really good at this. This shared side length here is congruent to itself. So, that's the way we'll write it. Okay, to write this statement, we're just going to literally say that AC is congruent to AC. Okay, so segment AC is congruent to itself, segment AC. All right, and if you guys remember, whenever something's congruent to itself, that's what's called the reflexive property. Okay, last thing, we can say that these triangles are congruent to one another. Maybe the first thing to notice is, yeah, side, side, side. That's what we expect here. When we go to write our statement, this is basically going to be a triangle congruence statement. All right, saying, this triangle is congruent to this one. All right, just a reminder, we can name this first triangle whatever we want. We just need to follow the same pattern on this other one. Okay, so I'm going to keep it simple. I'm going to call this top triangle ABC. Okay, so triangle ABC is congruent to. All right, and if I did, ABC, notice I'm going past the one marker, past the two marker. I'm going to do the same thing here and call this thing triangle ADC. All right. And actually, something you might have noticed, ultimately, this thing that we're trying to prove is that these triangles are congruent. They have the triangle congruence statement, right there. We could have just copied this. It just so happened I picked the same order of letters. All right. So really, you don't have to, stress this last step too often. It's normally given to us. It's what they're asking us to prove. Okay. So yeah, let's try another. Okay, so on number two, first things first, here's our very first statement. Segment AC is congruent to segment DC. All right, that is given to us. That's what I expect to see. Here's segment AC, here's segment DC. Okay, that's all I can get from that. So moving along, here's the next thing that they tell us, that angle B is congruent to angle E. Okay, why do we know that? Again, it's been given. Right, so let's go ahead and show it on our triangles. Here is angle B, and here's angle E. All right, now we need to find the rest of the information on our own. There's nothing else given to us, and hopefully you're noticing, oh yeah, we've got some vertical angles, which if you notice, that is the very next reason. We could have kind of used that as a clue. Yes, we can say this angle is congruent to this angle. All right. When you go to name the angles, remember we can't call this angle C because there's two angles with C as its vertex. So I'm going to name this one on the left going around it angle BCA. So angle BCA is congruent to, and I'm going to follow the same pattern on this one. Actually, really, I don't even need to follow the same pattern, but I'm going to call this one ECD. So angle, oops, let me make it red. Angle ECD. Okay, and yep, those are vertical angles. Last thing, we have angle side, which is exactly, the reason to have written out here. So now we can say our triangles are congruent. And yeah, I'm just going to copy this triangle congruence statement right here. So triangle ABC is congruent to triangle DEC. Okay, so yeah, you can kind of see these statements. They're not too shabby, especially if you're feeling good with the reasons here. So I'm gonna have you guys go ahead and try out one on your own. Let's skip past number 3 for now. I'm gonna have you take a look at number 4, and then we'll keep moving along. Okay, give it a try. Okay, so first things first. There's my first given statement. Angle B is congruent to angle D. All right, yep, it's given to us. Let's go ahead and show it. There's angle B. There's angle D. All right. Just, maybe by the way, this looks like it might be a right angle, but we have no reason to be able to say these are right angles. I just want to kind of point out, be careful of just kind of assuming things. That's a big part of these proofs is we don't assume anything. Okay, so anyway, moving along, here's our next given statement. Segment BC is congruent to segment DC. Okay, let's go ahead and show it. There's BC, there's DC. All right, so there's all of my given information. All right, next thing I notice is we have these vertical angles that we can say are congruent. So this angle here is congruent to this one, okay, which, you can see that's the next reason. All right, here's something kind of nice. These angles have a 1 and a 2 representing them. We can just name it angle 1 and angle 2. Okay, so that saves us a little bit of time. So angle 1 is congruent to angle 2. All right, just, to take notice, we have angle side angle as our reason here. Yep, that's exactly what is going on. Let's go ahead and write in our last statement that triangle ABC is congruent to triangle EDC. Okay, so let's see. Let's skip past number 5 for now. Number 6, I want to take a look at number 7 with you guys, and we'll keep moving from here. So let's take a look at our first given statement. All right, segment AD is perpendicular to segment CD. All right, so let's just go ahead and write it out. Segment AD perpendicular to segment CB. All right, that's been given to us. Here's the big thing about this. We can get some more information out of this given statement. Okay, just the fact that these things are perpendicular, that's great, but we can go a bit more. And if you guys notice, the next 2 reasons follow that flow that we're used to seeing. Definition of perpendicular followed by all right angles are congruent. All right, so what are the statements going to be? Well, let's make some sense out of this. If these 2 lines are perpendicular, we know that angle 1 and angle 2 are right angles. Okay, so that will be our next statement. I want to say angle 1 and angle 2 are right angles. Okay, just a reminder why, because that's the definition of perpendicular. That's what it means for things to be perpendicular. It creates right angles. Okay, from here, we can get another statement, all right? And this one's almost so obvious, it's easy to skip. But the thing we can say is since these are both right angles, that they are also congruent to one another. We can say that angle 1 is congruent to angle 2. All right. And the reason why we have to point that out is because we're trying to prove these triangles are congruent, and we do that by showing corresponding parts being congruent. Okay, so that's technically why we have to do this step here. And again, the reason all right angles are congruent. Okay. Cool. So yeah, that's what we can get out of a perpendicular line. Just always remember, we're going to get 2 additional steps whenever we're given perpendicular lines. Okay, now we can move on to our next given statement. Segment AB is congruent to segment BD. Let's go ahead and show it. Here's AB, there's BD. All right, that's, given to us. Last thing is we need to get one more piece of information. And yeah, hopefully you guys notice These are sharing a side length right here. All right, so I know that this side length BC is congruent to itself BC. All right, so there's my next statement. By the way, I could have called it CB, but I usually like to keep it alphabetical order. Okay, so segment BC is congruent to itself. That's the reflexive property. Okay, let's show it. All right, last thing, here's what I noticed. Right triangles, my first thought is, oh, maybe hypotenuse lay, but we do not have congruent hypotenuse on these two triangles. We do have a side angle side, though, and that's, you can see that's our next reason. So finally, we can go ahead and write our triangle congruent statement. So triangle ABC is congruent to triangle DBC. Okay, I'm going to go over one more before I have you guys try one out. I'm going to skip past number 8 for now, and let's take a look at number 9, and then I'll show you which one I want you to do. Okay, so yeah, take a look. First given piece of information, C is the midpoint of segment BE. Let's go ahead and write it out. All right, if you shorten that a little bit, I don't mind too much. I wrote the whole thing out. Okay, yeah, so C is the midpoint. Sorry, let me rewrite this. All right. And yeah, that's been given to us. Here's the thing. Whenever we are told something is a midpoint, we can get more information out of that. All right. And if you notice, the very next reason is definition of midpoint. That makes sense, right? We're told we have a midpoint. We're going to use the fact that that's a midpoint to get some more information. Okay, so let's make sense out of it. Here's C, and it's saying it's the midpoint of BE, this entire thing. Okay, well, if that's the midpoint of this entire green segment, we know this green segment is being cut into two congruent parts. Okay, so this is what we can say. This part of the segment is congruent to this part. Okay, or in other words, segment EC is congruent to segment CB. Segment EC is congruent to segment CB. Okay, and why? Because that's the definition of a midpoint. That's what a midpoint does. All right. When it comes to midpoint, that's it. We get one, additional step after it. All right. Next thing, BE bisects segment AD. All right. Well, there's our next statement. All right. So let's go ahead and write it out. So BE bisects segment AD. Okay. Why do we know that? It's been given to us. Okay. But we can get some more information. Just like midpoint, whenever you see something being bisected, you can get an additional piece of information out of that. Okay, so what does it mean? All right, well, BE is this line, right? This segment. Okay, but what's maybe more important is what is being bisected. AD is being bisected. Okay, so my focus here is about this thing. All right, and bisecting, a lot like midpoint, is something being cut into two congruent halves. Okay, and just a little reminder, sometimes a segment is bisected like this, and sometimes an angle is bisected. Okay, but either way, it means it's being cut into two congruent halves. So here's what I can say. This is congruent to this. Okay, so I'm going to say segment DC is congruent to segment CA. Okay, and again, why do we know that? That's the definition of bisect. Okay, so if you haven't realized it yet, midpoint is always followed by definition of midpoint. Something being bisected is always followed by definition of bisect. That's the way to think about this. Okay, so 2 pieces of information. I got one more thing I need to find on my own. And yeah, I'm noticing vertical angles. All right, they're numbered, which is nice. So we can say that we know that angle 1 is congruent to angle 2. Okay, why do we know that? Again, vertical angles. Okay, I'm taking a look at these triangles, and yeah, side angle side is the reason they're congruent. That's exactly the reason that it's here. So let's go ahead and write out our triangle congruency statement. So triangle ABC is congruent to triangle DEC. Okay, so hopefully you're starting to get the flow of these, and knowing, oh, midpoint, I'm going to do definition of midpoint. Bisect, oh, I'm going to get definition of bisect, and that those are giving you congruent pieces. Okay, so I'm gonna have you guys try number 8 out on your own. So go ahead and back up to that one. All right, give it a try, and then I think I have one more I want to do. All right, so we got angle 1 is congruent to angle 2. Okay, there's our first statement. All right, so why do we know that? It's given. This angle is congruent to this one. They're telling us that. All right, that's all we can do with that, right? There's nothing else we can do with that information. So moving on, we have our next piece of given information that EC bisects angle ACD. Okay, why do we know that? It's been given to us. But bisecting, hopefully immediately you think, oh, when something's bisected, my very next reason is going to be definition of bisect. And I'm going to be able to get some congruent parts for my statement. Okay, so what is congruent? What is being bisected? Well, let's point it out. Angle CAD is this angle right here. Okay, so, and that is being bisected by EC, but I'm more worried about what is being bisected, and it's that angle. Okay, so when an angle is bisected, it's got the two congruent angles. This angle is congruent to this angle. Okay, and that's my very next statement. I'm going to call this angle up top angle ACB. Okay, so angle ACB is congruent to, and the one on the bottom I'm going to call DCB. Angle DCB. All right, and again, we know those are congruent because that's the definition of bisect. That's what happens when something is bisected. Okay, there's all the given information, 2 pieces on each. I need to find one more thing, and yep, I'm noticing they do share a side length here. All right, so I know this side length CB is congruent to itself, CB. I'm just going to call it CB this time. All right, so segment CB is congruent. Sorry, I'm getting a little sloppy. To congruent segment CB. Okay, whenever something's congruent to itself, remember, reflexive property. That's what we expected. Okay, and let's show it. All right, I'm looking at my triangles. I got 2 angles and a side in between. Angle, side, angle. Yep, that's what I expected. All right, so now I can write out my triangle congruent statement. Angle ABC is congruent to triangle DBC. Okay, cool. So I got one more I want to do with you guys, and then I'll let you try some of these others that we skipped past. Let's take a look at number 10 for our last problem. All right, so first things first, here is my first given statement. Let's write it out. C is, I'm gonna take out the word the. So C is the midpoint of AE. I'm just gonna shorten it to that. All right, first things first, I want you to be thinking, oh, midpoint. My very next reason is definition of midpoint. That's what I expect to be right there. All right, what can we get when we have a midpoint? Well, if C is the midpoint of AE, this entire segment, again, it's cutting this segment into 2 congruent halves. All right, so we can now say that this is congruent to this. All right, that's our very next statement. I'm going to call this segment AC and say it's congruent to this one, CE. So segment AC congruent to segment CE. Cool. That's all I can get with that. Moving along. Now I have another piece of given information. All right. AB is parallel to CD. All right. So let's go ahead and write it up. So segment AB is parallel to segment CD. All right. So here's, something we don't see very often. Not a lot of these problems have parallel lines. Okay, but here's something I want you to just kind of remember. Parallel lines cut by transversals. We have 4 different types of angles we get. We can get corresponding, alternate interior, alternate exterior, and same side interiors. All right. And normally when we have parallel lines on these types of problems, we end up with alternate interior angles, which is why it's one of the reasons that I kind of feature, on the very bottom here. All right, that's why I put it as one of the reasons, that you copied down. But that doesn't necessarily mean all parallel lines give you alternate interior angles. All right, if you guys take a look at these, let me highlight them. There's my parallel lines. Let me make them red because that's what I usually do. There's my parallel lines, and here's my transversal cutting over them. Okay, angles 1 and angle 2 are actually corresponding angles on the same side of the transversal, the same side of the parallel lines, which, we could see that right there. Okay, but I'm trying to get you into the mindset of, what if we didn't see the reasons? Okay, we would be able to figure out, yeah, they're corresponding angles. All right, and the big thing we know about corresponding angles is they're congruent. Okay, so there's our next statement. Angle 1 is congruent to angle 2. Okay, I'm taking a look, and that's 2 pieces of information. And I'm wondering, where's the third thing? I'm not seeing vertical angles. I'm not seeing any shared sides or anything. And if you guys notice, there's actually one more piece of given information. Okay, a lot of these problems only give us 2 pieces of given. This one's given us 3 of them. Okay, so angle B is congruent to angle D. Yeah, they're telling us that is true. All right, so we can show that this is congruent to this. All right, 2 angles and a side not in between, angle, angle, side. Yep, there's my reason. Now I can write out my triangle congruent statement. So triangle ABC is congruent to triangle EDC. Okay, so yeah, we're putting the pieces together. We, started with the reasons. Now we're doing the statements. As you can imagine, we're eventually going to get into doing the entire proof on our own. All right. So hopefully you're starting to feel comfortable with this. I know it's overwhelming. There's a lot going on here, but it's a really, really good review of the stuff we've learned, the last past month or so. All right. So yeah, try out these other problems. If you run into any issues, please ask me some questions. Bye.